This is an Akai turntable. This one's an AP-D33. I sold this one, I think about 5 years ago now, I guess. And the fellow that bought it from me came back and said, hey, you know, it's been working great, but now I'm listening to it, and every so often the speed jumps. So I'm going to have to let this play and see whether it does. He says it tracks perfect, and then all of a sudden the speed will go off. So I was going to let this play for a bit here. And obviously I can't play this because... Let's try adjusting the pitch ever so slightly. I'm going the wrong way. So I'm just going to let this thing play. I'm going to listen to it, obviously, and listen to see if it does change. And we'll follow up with the camera if it actually does do anything. He says it usually will play for a while, and then it'll just jump in speed and come back. It's doing it a bit. See there? See this? So there's the problem there. It's changing. Not by much, but it's changing a bit. You can see it coming out like it's coming out of lock. So there's what the problem is. We may have our work cut out on this one. This is a direct drive. So I don't know where we're going to find the problem on it, to tell you the truth. But as you can see, it does seem to have a problem. And it's been playing here for, I don't know, 5 minutes or so. Just seeing if it's the control that's bad. Is it the switch? Now it's drifting the other way. I set it up. Interesting. It's got to be something in this feedback circuit. It could even be the switch for that matter. It could be the switch is bad. It goes up to 45, no problem. Could even be the switch. We'll pull this one apart and see what's going on. On this unit we have speed setting controls and a pitch control over here, and this is the speed selector. So the speed selector switches, actually I guess these are the speed controls over here. Yeah, these ones are the speed controls. I don't know what these are. These are probably phase controls for the 3-phase. And I say that because the speed, the switch is connected over here. So basically one is set for 33 and one's set for 45, and all the switch does is switch between the two of them. We have an oscillator in here that generates a 3-phase signal for the 3-phase motor. This is just a coil pack. And on here we'd have our driver transistors and our servo, our feedback loop. There'll be a frequency generator on the motor itself, which provides a frequency that is proportional to the speed that the motor is going. So the faster the motor is turning, the higher the frequency. And that frequency is run through a comparator, and the voltage charges up one of these capacitors, and they use that and compare it to the reference and generate an error voltage to either signal the servo to speed up or to slow down. That's basically how these units work. So I'm going to pull the board. We're going to take a look at the board, maybe check some of the capacitors out. I really think the problem is probably the switch over here, because when I tap the unit, that's when it seemed to vary in speed. So to open this up, we just have to pop open the gate, pop one side open like this, and then I can lift the wires out. This is a low insertion force. It's not zero, but it's low insertion force. And then I can pull these wires out, get them out of the way. Now I can lift the board out and we can start checking for ESR on some of these caps and see if any of them have gone bad, because that could cause a speed variation as well. In particular, some of these small ones down here. I believe these are solid. These are not electrolytics. These are solid. Not a tantalum, but similar. And these were the ones that were so problematic on Sony Betamax machines. In the early 80s, when I worked for Sony, we had to cap literally hundreds and hundreds of these machines. We had to change all these blue Sanyo solid capacitors because they all were bad right from the factory. Get the board out of the way here. I guess I'm going to have to cut a couple of the zip ties. It's funny, I sold this unit several years ago now. I forget exactly the year, but and the guy's been using it, and he loves it. He thinks it's the greatest turntable he's ever had. Yet, when he brings it to me with a cartridge that's bent. Oops. Yeah, the shank is bent on the stylus. No, I didn't do that. That's how it arrived. I took the cartridge off before doing any work, and it was tied down when he brought it to me with a twist tie. Okay, let's just start measuring some ESR and see if any of these caps are bad. We'll check these little solid blue ones first. But those are not electrolytics though, so I don't know that you could trust that reading, because these are a solid cap. There's 3 of them here. The next one I think is it this one? And that one there, 3.1 and 3.3. And that's probably about right, because they're a 3.3 microfarad. At what voltage are they? 16 or 25? 16 volts. So 3.3, like, you can't even measure that. Same with the other one down here. This is a 1, I believe. What does this one say on it? Oh, it's a 0.47. So we're not measuring those ones. But I'm sure that those ones are fine because, as I said, they're not an electrolytic. So there's nothing in them to dry up. They're not tantalum either, but they're an aluminum solid capacitor. But the ones I'm more concerned about are like these ones here. Well, 0.9. That's probably okay. What size is it? 10 volt 100. So 100 at 10 volts should be 1.2. What about these other ones here? There's another one here, which is here. Where's 3.3 at 50. You can actually measure it from the top here because the leads are long enough. 2.3. That one looks okay. Three of them in a row here. 1.5, that looks okay. 1.3, 1.9. These caps are all looking good. There's two more over here. 0.3, 0.4. A couple more over here. 0.3, 0.38. Make sure these are completely dead. 0.05, 0.03, 0.4, 0.4. Damn, I think these caps are all fine. Just like they were the last time I had this. So I gotta think the problem is mechanical. I'm thinking probably this switch over here, because I doubt that he switches much between 33 and 45. Most people don't. You know, most people don't play a lot of 45s. They play mostly 33 RPM. So it's possible that just over the years the contacts have oxidated a bit. So we'll just try putting some deoxit once I mount the board again, of course. Anyway, this is how you do, and test it out and see. And that may be all that's wrong with this turntable. My favorite wire wraps, I hate them. Pop the ribbon connector back together. Okay, come on.
Đặc biệt là bài hát này là mình đi respect nhau số nhằm chỉ là đặc biệt mình biết người nghe.
My favorite type of switch. Not. See if I can get some cleaner in here. I may have to take the switch apart. Try that. Okay, I'm just going to throw the bottom on it. We'll put the platter back on, test it, and I'm going to let it run and make sure that the speed is good. Okay. So, I'm going to let this play. I'm just going to make sure it's going the right speed. And we'll let this play and see whether it's going to change at all. We'll just look at this strobe right now. I'll tap the unit like I was before. Aha! Looks like it was the damn switch. Probably just some oxidation. It's me doing the switch now, obviously. So I'm just going to let this run for a while. Keep an eye on it, and fingers crossed we got the problem solved. Thanks for watching. We'll catch you in the next one. Bye for now.